1 or 2. Okay, so first we have studied QoS for MQTT QoS. Now there is another characteristic about MQTT communication. It's retained messages. Okay, so what are retained messages? For a client that publishes data has no guarantee that subscriber actually receive the message. So this is obvious in publish subscribe. We don't have guarantee that it has been received by the receiver. So publisher can only make sure that data is delivered to the broker. Well, why? Because at the end of the day, the publisher is not connecting to the subscriber. The publisher connect to the broker, broker connect to subscriber. So the publisher can only transmit to the server, that is the broker. Okay, so publisher can only make sure that data is delivered to broker. This is what is mentioned here. Likewise, a subscriber also has no guarantee that a publisher will publish a topic in which they are interested. You may have subscribed to a topic, but you never receive a data. Why? Because no publisher has given data for that topic. Okay, so subscriber will need to wait until next message is published to the topic of interest. If no publisher submit data for that topic, so the subscriber will never receive any data. So what are in all this? What are retained messages now? A retained message is an MQTT message, a normal MQTT message, but with its retained flag set to true. So in an MQTT packet, there is a flag. Okay, there is a control flag that you can set to true or false. Okay, this is called the retained message flag. Okay, if you set it to true, what is the meaning of this? If you set it to true, you will see down here it is. The meaning is explained. So a publication may be retained. Okay, what does that mean? If we put this flag to be true, a publisher can mark a publication, that is a message, as retained. If it is marked as retained, the broker, here is the answer. Well, what is a retained message? The broker or server remembers the last known good message of a retained topic. Okay, so when you publish a message, it is for a particular topic. Now you say that this is retained. This message is retained. So automatically we are talking about a particular topic. Now this topic is retained means what? The broker gives the last known good message to new subscriber. That is last data that we have received for this topic will always be available, should always be available at the broker. Okay, that is when later I have a new subscriber that comes in. So normally, if we don't have retained message, when a subscriber subscribes to a topic, the subscriber has to wait for the next data to come, for the next data, that when the next data will come, when the publisher will publish any data for that topic, then the subscriber will receive the data. What we are saying here, we're saying if a topic is retained, a message is retained, it is saved at the broker. When a new subscriber comes in, it always gets the value. Okay, the new subscriber does not have to wait for a publisher to publish a message in order to receive its first. The first one, it will receive the last known message for that topic. So this is a retained topic or a retained message. That is, the last value is saved at the broker. When we have new subscribers coming in, we give them the last known value for that topic. You have understood this point? Anyone having a question about this retained message? I have tried to explain it in very simple terms. So normally, when a subscriber subscribes to a topic, it has to wait for the next message to come. But when a topic is retained, the subscriber don't have to wait. It gets the last value that was published before. Okay, obviously it's not the most current one, but the last value that was published before. So this is called a retained message. Let me continue and see if, okay, so the second characteristic, first one was QoS, second retained. Now there's a third one about MQTT messages, one that is called the last will. The last will. What is the last will? All these things in we use it when we develop in MQTT. This is why I'm having to cover all these in my discussion here. Okay, and you will see it in examples as well. So the third characteristic or points that we need to know about an MQTT message. MQTT can be used in scenarios that might include unreliable networks. We have already said this at the beginning of this lecture itself. Intermittent networks, unreliable network. So MQTT client disconnect due to why very often MQTT client get disconnected due to loss of connection, because we cannot guarantee a connection which is always available, and low battery levels. The client goes off, battery is too low, whatever. Okay, so for this reason, you can disconnect from a publish subscribe from your communication. So the loss will allow client to respond to ungraceful disconnection. What happened when you are going to disconnect? Okay, or when you are disconnecting, there's a loss message that is sent, or there's a message that is sent to all subscribers or to all subscribers for this particular publisher that inform, yes, this publisher or this subscriber is no more available. That is, you have stated your loss will. Obviously, this happened at the broker. This is, I've not said it, but it is quite obvious that the loss will be saved at the broker. And once a disconnection happens, the others are informed, yeah, this particular subscriber or this particular publisher has been disconnected. This is called the loss will message. Let me see. Okay, it is. Each client can, a client after you, a client can be a publisher or a subscriber. So each client can specify its loss will when it connects to a broker. So when you connect to your broker, you specify your loss will. Okay, loss will message is a normal MQTT message with a topic, retain flag. So you know now what is a retain flag, and QoS. Normally in all messages, in all MQTT messages, this is why I have gone through each one of them. You will have a topic, you will have a retain flag. I've already explained what is a retain flag. It can be true or false. Okay, and you will need to specify which QoS, 0, 1, 2. Okay, so this needs to be specified in your MQTT message. Now, the loss will, broker store the loss will message until it notices that client has disconnected. So the loss will message will be stored at the broker. When the broker notices that a client has disconnected, the broker then sends the loss will message to all subscribed clients, to all clients that have subscribed to this particular topic, whatever. Okay, this because you see in the MQTT message there is a topic, so we are referring to a topic as well. So all the clients will be informed, yeah, this for this particular topic, this publisher or this client has disconnected. So this is called loss will. So when you connect, when you connect to a broker, you can specify your loss will, and loss will is just a message that will be sent to others when you are disconnected. That's all. Okay, there's no data that you're transmitting actually, but it's just that others will be informed that you are no more available. That's all. This is the loss. This is the loss will. It's not difficult to understand. It's just a message. But then you will need to send your loss will. If you don't have a loss will message, then you may be disconnected. No one will know that you have been disconnected. So this is the difference when you specify a loss will and when you don't specify a loss will. And this is normally stored at the broker. This is an example. You know what is a testament? Okay, loss will and testament. Okay, your testament is what are you prescribing when you will die? Okay, what are you prescribing about your property? Who should get your property? Whatever. The same thing is happening here. You have a client ID for a particular client for a particular session. This is username, password. These are optional things that we specify in our message. You see, loss will topic. Loss will topic /will. Okay, /will. This is the loss will topic. Loss will QoS2. Loss will message. Here it is the message that we will transmit when I am disconnected. When this client will be disconnected, the loss will message should be unexpected exit. This is what I want others to know when I die. when I am disconnected, inform all others about this information and expect exit. So these are the information that will have to be transmitted when this client one, when client one will be disconnected. So this is the loss will and testament for client one. So this is a third, yeah, it is a third characteristic. So we have seen QoS, we have seen retain, we have seen loss will. Okay, recall this very well. These are technical things, but if you will be assessed definitely on those characteristics of MQTT. This is an example, publishing to a topic. This is a publisher sending something for a particular topic. Let's see the packet, MQTT packet for publish. You need to have, this is a packet ID. Topic name, you notice topic/1. This is just a name for that particular topic. QoS, so you understand what is one means here. QoS is one. Okay, what is one? At least once. You recall, at least once. This is QoS one. Retain flag, I see it is false. So you understand? Okay, this message will not be retained. This value will not be retained. Payload is actual data. Recall topic 1/1. Okay, and here we are sending 32.5. The temperature to be 32.5. This is what we are sending. This is an MQTT packet for publishing. For subscribing now, let's check for subscribing. For subscribing, after you subscribe to a particular topic. And how do you specify a topic like this? Home/ground floor. This is just like in home you have ground floor. In ground floor you have kitchen. In kitchen you have a topic called temperature. This is what is. So these are different locations. Maybe, for example, office, conference room. We want to check the luminance. The topic here is the luminance. Now you can specify. For example, you use wildcards. This is an interesting feature when you specify topics. You can have single level. So have a look at this. Home/ground floor. In my house, in the ground floor, I want to have temperature, but temperature for what? You see here, there's a plus here. There at the top, it was home, ground floor, kitchen, temperature. So I know temperature in kitchen. But here, I say home, ground floor, I see a plus, then I see temperature. What does that mean? I want to have all temperatures on the ground floor from all the rooms in the ground floor, not only kitchen, but all. The plus here means for all temperatures on ground floor. To subscribe to all temperature readings in all the rooms of the ground floor. So this is called a wildcard. You use a wildcard. You can use it for middle, or you can put it at the end. When you put it at the end, it is a hash symbol. When you put it at the middle, it is a plus symbol. So multi-level here, home, ground floor, and anything that will come after. Okay, all topics, all places, all topics. To subscribe to all the readings, that is all topics, in all the rooms of the ground floor, not only temperature, not only the temperature. When you put hash here we have specified in all rooms, but I want to have the temperature in single level. All rooms, but temperature. Here I'm saying ground floor all. Ground floor all means all readings, all the rooms. This is what we are saying, because we are not specifying which room, we are not specifying which topic. So all rooms, all topics. This is what we are saying, multi-level here. These are called wildcards. You will have other examples. The same thing I've just explained here. You'll see a concrete example for the first one. When you have a plus here, so it means living room, kitchen, kitchen again. But brightness, this will not be sent. You see the green one. The green one, first two, they are green. The third one, it will not be transmitted. Why it will not be transmitted? Because it is my home, it is ground floor, it is kitchen, but it is not the topic. I have not shown interest in brightness. The fourth one, why it is not, we will not transmit. My home, but this one is first floor. On the first floor, there is a kitchen, there is temperature, but I'm not interested in first floor. So this will not be transmitted. The fifth one, why it is not transmitted. My home, ground floor, kitchen. There is another one here, fridge. In fridge, I want to have the temperature. So I'm not interested in this one. Okay. Whereas for all, you notice here, my home, ground floor, living room temperature, my home, ground floor, kitchen temperature, my home, ground floor, kitchen brightness, because I've said all readings for all the rooms. my home first floor. No, I've said, excuse me, I've already said ground floor. So first floor is excluded. Okay, so these are called wildcards. We can use wildcards to specify terms. So we have seen publishing. It's publishing to a topic. Let's see, this was subscribing to a topic. To subscribe to a topic, this is a MQTT packet for subscribe. Get ID, QoS, 1, topic /1, QoS 2. You see, I can subscribe to different topics at different QoS level. This also we want to show to you here. Different topic. This subscribe packet is subscribing to different topic at different QoS. Topic 1, QoS 1. Topic 2, QoS 2. Here it is. It is mentioned in the packet here. Then you see here, when you send a subscribe, you get an acknowledgement. Subscribe act, an acknowledgement, and this is what is written in a subscribe act. Okay, get ID, return code 1, return code 2. Okay, this is returned to the client. This is a subscribe act, and if ever you want to unsubscribe, you sit down here and subscribe a act. Okay, this we have more or less already seen. I've already explained this to you. Topics. How do we specify topics? It is hierarchical with each subtopics: country, region, town, postcode, just like we had before. Home, first, second, ground floor, a room, temperature. So here, same hierarchical structure. A subscriber can subscribe to an absolute topic, one particular topic, or can use wildcards. So you understand what is use wildcards here. Single level wildcards plus can appear anywhere, and multi-level wildcards hash symbol can appear at the end of the hash. Normally appear at the end, because after hash means all, everything that comes after. So wildcards must be next to a separator. Okay, separator, those slash symbol. You'll see some examples below. So and also very important, it cannot be used wildcards when publishing. When you publish, it should be published for one particular thing. You cannot say all thing you're publishing the same value. This doesn't make sense. So you cannot use wildcards for publishing, but for subscribing you can use. See the example below. UK Hansley is code 1 energy consumption. This is a particular energy consumption for one house in Hansley, in a particular area or whatever. Okay. Then the second one, UK answer Hansley plus energy consumption. That is energy consumption for all houses in Hansley. So this is plus. That is any code, any house. Okay. We want to have all energy consumption. So you can continue down here. UK Hansley for that code, everything. So details of energy consumption, solar alarm for all houses in this particular code. This more or less I've already explained, but this is an example. Yeah, this is a scenario. Have a look at this scenario where you have a Bluemix IoT service. Bluemix is an IBM product. Okay, you have a device here, device side, which can be a switch, for example, in this case, a switch, and you have an application here, which can be a mobile application. Okay, you want to send a message to switch on a lights or whatever. Okay, so this acts as a client to the broker, and the mobile application as a client to the broker. And you see here, clients connect to a broker. So both clients connect to the broker. Client subscribes to topic. Okay, client subscribe. Toggle light 1, toggle light 2, toggle light 3. All free. I subscribe to all free lights. Okay, and I subscribe to all. Client can publish messages to topics. So client.publish. Toggle light 1, toggle. That is, I want it to be toggle or not toggle. So all clients receive all messages published to topics they subscribe to. You should have subscribed to that topic for you to be able to get the value that is being published. So messages can be anything, and you can see here MQTT hypothetical light switch. There is a light switch. You through your cell phone, you publish something. Light switch 1 toggle. You send the value toggle there. For 1 toggle, that is switch it on and off. Okay, broker. It sends the message toggle because a data has been received, and this toggle switch was subscribed to this particular a topic. Okay, so you receive the value now. A value is coming, has just been reached, and is being transmitted. Now toggle, it received a message toggle, so it switch on and off. It toggle the switch. So this is how you can implement a real application using MQTT. If you want something to happen when you send a message, or you trigger some action or whatever, you can use a MQTT for this purpose. Yeah. Now, when it comes to implementation, so I've just shown to you a hypothetical light switch. If you are to implement this scenario, this application where you can control the switch in your house or whatever using a MQTT, how you will go about doing it is implementation. I have a full session next week on MQTT implementation, but already this week I will give you some work to do to familiarize you with MQTT implementation before we discuss it next week. But before I give you the homework, I will explain to you how normally it is. So normally there are MQTT brokers, specific brokers. No, those brokers, you will not have to implement it yourself. There are online brokers already available. So when you're implementing an IoT application where you have a publisher and a client, a subscriber, the broker, you have brokers that have already been implemented for you, and they are publicly available. You can connect to the broker, you can transmit your data to those brokers and receive data from those brokers. For example, there is Mosquito. Mosquito is a very popular one. HiveMQ is another very popular one. Okay, these are online brokers. They're already available. You just connect to those brokers, you transmit your data, and you receive data from those brokers. So MQTT libraries are available in many programming languages. One of the very prominent MQTT library is Eclipse PAHO. Now, to develop your clients, you need to use a particular platform. So Eclipse PAHO allows you to develop your publisher and your subscriber. Broker is already available. Eclipse PAHO it can connect directly to Mosquito because Mosquito is designed for Eclipse only, Eclipse PAHO basically. So mainly you can use Eclipse PAHO to develop your publisher and subscriber, and you use your Mosquito as your broker. I was checking it this morning, so if I can show to you if my whole screen is shared, if I'm not mistaken. Wait, this is Eclipse PAHO. You see here, the link also is already given at the top. So what it says, what is Eclipse PAHO? PAHO is an Eclipse IoT project. MQTT and MQTSN are lightweight publish subscribe messaging transport for TCP/IP and connectionless protocols. The Eclipse PAHO project provides open source, mainly client-side implementations of MQTT in a variety of programming languages. You understand? So basically what it provides, client side. It allows you to develop when we say client side, to develop your publisher and your subscriber in a variety of programming. You want to use Java, it is there. I guess there is a series, I don't know whether it is mentioned here, a series of programming languages that are already supported. Okay, for example, you can implement your client in Java, use in Eclipse PAHO, your subscriber and your publisher. I'll show to you now Mosquito. Yeah, you see it's written Eclipse Mosquito. Okay, and open source, here it is, an open source MQTT broker. So it's already available. You just need to know how to use it. It's already available. So you don't have to implement the broker. The broker is already there. You just need to know how to implement your client to connect to that broker. Okay, and you have those popular brokers, open source brokers, which is very convenient. Let's see what is written here. Eclipse Mosquito is an open source message broker that implements MQTT protocol version 5.0 and other versions are well. So Mosquito is lightweight and is suitable for use on all devices from low power single board computers to full servers. So any type of devices you can connect to this broker. So the MQTT provides a lightweight method for carrying out messages. This is what we have been studying since this morning, the subscribe model. This makes it suitable for Internet of Things messaging. This is why we are studying it in this module. Okay, this makes it suitable for Internet of Things messaging, such as with low power sensors or mobile devices such as phones. So after your client can be a mobile phone, embedded computers, or a microcontroller. On one side, you have an Arduino. On the other side, you have a mobile application. Okay, and then you transmit using MQTT between your Arduino that is connected to some sensors and your mobile phone. So at the end of the day, if you're able to implement for your mini project something like this, okay, using MQTT, it's already very good because you will be mastering the whole chain of using MQTT to trigger some action on your sensor or reading values from your sensor. So, and this is one is freely available, the broker. Okay, you publish your data there, and then you capture the data at the client side on your mobile application. So the tools are already here. Next week, I will give you sample code as well, because I will implement a client, a publisher. I will connect to a broker who will have it at the subscriber with codes and everything. And I'll show to you also Hive MQ. This is another one. IoT application can generate a lot of data. It is critical to select technology that is designed to move IoT data across networks and cloud a platform. So basically you need the necessary platform. So here is one that is available again. Okay, connect any device, fast instant data delivery to Hive MQ. Okay, this is an industry level a platform. But anyway, Mosquito works very well. If I have to develop, so I will choose Eclipse Paho with Mosquito, and you should be able to develop the whole thing because both are Eclipse based, and you are familiar with Eclipse. Let me get back to the slides here. So you see here, if you are to develop an MQTT communication between a client server, your whole IoT system, so you'll need to develop your publisher on Eclipse Paho, you will develop your subscriber on Eclipse Paho, and then you connect them to Mosquito, which is an online broker. So basically, if you're able to do this, you have already learned like how to use MQTT. You will be able to develop any MQTT system. This is my objective, that you should be able to do to do it. And if ever when connecting to your broker, you get one of those values, 0 means connection accepted, 1 means connection refused, 2 means connection refused, identifier rejected, 3 means connection refused, server unavailable, 4 means connection refused, bad username or password. So you need to recognize this. And after you can develop your MQTT client, which a client can be subscriber or publisher, by programming directly to the MQTT protocol specification, but this is difficult. Okay, however, it is more convenient to use a pre-built client. Pre-built client that are already available. This is what I've been telling you. Open source client available in Eclipse Paho project. It is already available, and whether you want to develop C, C++, Java, JavaScript, Python, all these languages you can use to develop your client, and it is already pre-built. So instead of starting from scratch, you use your Eclipse Paho, you develop your client. Client for other languages are also available, like Delphi, Erlang, .NET, and everything. Not all of the client library listed on mqtt.org or current, so you need to check which one. But those I've mentioned, like C++, Java, definitely it is current and it is available. You can. I think most of you are developing in Java, so you can develop your clients in Java in Eclipse Paho. And this is for developing your client. The broker is already available. For the broker, you just need to know how to connect to it and how to publish your information, create topics and publish your information to that broker. This we will see next week in terms of coding for MQTT. But for you to be able to understand next week lecture, so I want you to do this exercise. I'll prepare something that you can do on Thursday in the for your lab time. Okay, so or you do it any other time that that you want, since it is online. So go through the Hive MQ website. There are two brokers I'm introducing to you. Hive MQ. Okay, investigate the capabilities and features provided by the broker. Just go through it, read what are the capabilities that they have, this broker, how to connect to it, things like this. The same thing you do it for Mosquito. Okay, investigate the capabilities and features provided by the broker. These are brokers available online. Then you identify some application use cases which can be implemented using MQTT. For example, I've given you a use case where you have a switch for lights. You can toggle the lights. This is a scenario. Identify other scenarios where you can use MQTT. Then you go through Eclipse Power as well. Okay, read about the steps involved in developing an MQTT client. This we will need next week. Next week we are going to develop an MQTT client. Okay, so I'll show you the steps, the different codes and everything. But it will be better if you go through the steps before the lecture for next for next week. That is next Monday. Okay. So if you do this, we should be ready for our next lecture. Next lecture mainly will be MQTT implementation, client, that is publisher, subscriber, broker. These three things. We have discussed lengthily today. Recall three things: QoS, retain flag, loss wheel that we have discussed. And obviously, by now, this publish subscribe should be very clear to you. What are we talking about? Publish subscribe. What is a subscriber? What is a publisher? What is the role of the broker? And how messages are exchanged. After completion of this lecture, I think this question should be very clear to you. Now, we'll need to see in terms of coding. Okay, and I want you, if possible, to use it even in your mini project, depending on which mini project you're doing. That's is not that you should be using MQTT, but if you develop something on one side, your Arduino connected with some sensor, you're publishing your data to some broker like Mosquito, and then a mobile apps is interacting with it. Already, if you do this, for me, it is a complete system that that can be submitted for your mini project. But it should be something interesting with a few data and everything there. Okay, so this is it. I think yeah, I don't have, yeah, you have a series of links. You can check it out for further reading and additional resources. Yeah, this is it. Let me go back to our